In the previous video, we created a stateless web application. Now we are going to add a database to our backend. For this purpose, we will create a DynamoDB database table and then use the DynamoDB Node.js client to create, read, update, and delete items. And we will add this functionality to our little blog application. I'm signed into the AWS Management Console located in the Frankfurt region, and I've already opened the DynamoDB dashboard. You can find it by clicking on Services and then selecting DynamoDB here. I don't have a DynamoDB table yet, so DynamoDB is a database as a service offering. You don't need to manage the database server on your own. You can use the web dashboard to create tables by clicking on this button and going through the wizard. However, we will use the serverless framework to programmatically create a DynamoDB table for us. So I click on Cancel here. I switch to my editor and I've already opened the serverless YAML file here. What you can see is that you can specify resources which will be provisioned by using CloudFormation. So I replace the dummy code here, something that I've already prepared, and this will create a block table resource for us. The block table resource is of type DynamoDB table, and the DynamoDB table needs a couple of properties. It needs a table name, in this case block table. We need to specify attributes, and we need to specify which of our attributes is the hash key, and optionally we could also specify a range key, but in this example I'll just stick to having a hash key. So I specify an attribute, article ID, which is my hash key. The hash key in DynamoDB is something like a primary key or a partition key that you might know from other databases. Another attribute that you need to specify is called provision throughput, and it determines how much throughput you can use and also determines the cost of the DynamoDB table. You can read up in the DynamoDB documentation to learn more about this. So I'm going to open my terminal and switch into my service directory and then simply type SLS deploy to provision my DynamoDB table. Now the deployment has finished and we can switch over to the AWS Management Console to see if the table has really been created. So as you can see now here I have a block table which is active and which has the partition key or hash key, which are synonyms, with name article ID, and it expects partition keys or hash keys of the type string. As a next step, I want to connect our application to the DynamoDB table that we just created. For this purpose, we need to install a dependency, the AWS SDK. First, I'm going to create a package.json file via npm init -y, and then I will install the dependency via npm I for install --save, so it gets saved in the package.json file AWS SDK. Okay, the dependency has been installed. We can see here the node modules directory with the AWS SDK and dependencies of the AWS SDK. We can also see in the package.json file the dependency has been added to our dependencies here. Okay, now we can go to the create.js file and connect our application to the DynamoDB table. Right now our create function handler just sends back some dummy data, a hard-coded response with an HTTP status code 200, OK, and a JSON in the body. By the way, you might wonder about the structure of the response. So there are different ways to integrate API Gateway with Lambda, and this style is called Lambda Proxy, and it's the default that Serverless framework currently uses. Using this integration style, you can specify your HTTP request programmatically, as we do here. You could, for example, also add HTTP headers or other things programmatically. And this is, of course, again, much more convenient than doing it on the AWS console, which you would need to do if you would use the plain Lambda style instead of the Lambda proxy integration style. Okay. Now the first thing that we need to do is add our dependencies to the create.js file. So going to add that here. So the first thing that I add is the AWS SDK, the module that I just installed. And then I use AWS to create a new DynamoDB client. DynamoDB offers different clients. I'm going to use the document client, which is a more high-level client that is more convenient, more developer-friendly and easy to use. Now I'm going to replace this console log statement with a Dynamo request. And I'm going to issue a put request to create a new item. And the put method needs two arguments. The first is params, and the second is a callback. To not get my naming confused with this one here, I'll name it put call. Okay. Now I need to implement the params and the callback. Can look up the DynamoDB Node.js SDK documentation how to do that. So first we need a JSON file that specifies the table name and specifies the item. Right now I'm going to use a hard-coded ID, our article ID, and I'll give it a second attribute, the text that I retrieve from our event. And I have validated this previously here. The second thing that I need to do is specify my put callback. And for that purpose, I will create a new variable, callback, and I'll assign this method, which is an error first callback function. I'll check if there's an error, and then I can scroll down and copy this part here, white spaces. So here I prepare my response, and instead of this dummy response, I want to send back the item that has been created in DynamoDB. So instead of sending back this object here, I'm going to send back result.item. If you want to learn more about the structure of the result, you can log it out on the console and view it here. Okay, I'm not going to do that here. Okay, and then when the put callback has executed with the result, we will prepare the response and we will call our function handler callback with the response that we prepared here. And this is executed down here. But don't get confused about the order because it's all asynchronous. This is the callback that will be processed last, unless there's an error. Now let's locally invoke our createArticle function with the event.json file that we have up here. Gives us back a status code 200, and we switch over to the AWS Management Console. We can see that the item has been created. Hello world. However, if we want to create more articles, we would need to increase or change this article ID number. So this is certainly not perfect yet. What I'm going to do is I will add a module named UUID via npm i UUID, and this will install the UUID module, which I can add or import up here. And then I can use it down here and replace my hard-coded article ID. And the way I can call or I can use UUID is by specifying the version number of the kind of UUID I want to create. So let's repeat the local invocation one more time. Let's go 200, and I refresh my table, and now I have created an item with a randomized UUID. Alright, it seems to work, but does it actually work if we deploy our service? Spoiler alert, it won't. Nevertheless, I will deploy the service as it is right now and show you what goes wrong and why. So if you run into the same error later when you're developing on your own, you know how to fix it. Let's switch over here and deploy our service via SLS deploy. Okay, we have deployed our service, and I will repeat the invoke command, except I will not invoke it locally, but remotely. And here you will run into an error. This is not a bug. You might get some info what went wrong. We could not save the record. Here we don't really know why, so let's check the logs. We go up here a little bit. We see that our Lambda function is actually not authorized to perform the put item request on our resource, on our block table resource. So let's fix that. And the way to fix it is via our serverless YAML file. Here you can see that you can add IAM statements or IAM role to your service. By the way, this is supposed to change in Serverless Framework version 1.8, so if you're using a newer version of the Serverless Framework, please head over to the serverless.com website and check out the documentation. So, if you're using Serverless Framework 1.7 or below, you can add the following IAM role statements where you specify which kind of actions you want to perform. And what's missing here is your ARN, your resource. How do you find that? Let's switch to the AWS Management Console. And on your DynamoDB table, there's a tab named Overview. And if I go down here, I see the Amazon resource name. By the way, this is something that you probably, let's switch back to the serverless YAML file, that you probably wouldn't want to hardcode here. Serverless also allows you to specify variables that you can use in your serverless YAML file. So check out the serverless documentation, how to do that. Okay, now let's redeploy our service and try again. Okay, we have deployed our service. Let's invoke it. Now you can see we get back a status code 200. And if we check our table, we should see a third item that has been added. Great. Before I move on implementing the read, update, and delete functions, I want to refactor my code a little bit. Because right now the persistence, business logic, and Lambda function code is all tangled together. And I want to separate it a little bit if you want to use test-driven development, write unit tests, something like that. Separating your business logic from your Lambda function will come in handy. So the first thing that I will do is create a model.js file. I've already prepared some code here, so I'm just quickly going over it. I have moved my UUID here. I have created an article class that captures the properties of my article. And then I have some helper methods like create article that transforms my Lambda function event and callback, uses that in a validation step here, and then creates an article object and returns that article object using the event information. And here I have some more helper functions for validating my event and throwing an error if the validation fails. And then I'm going to export my article class and the create, read, update, and delete methods. One more layer of abstraction that I want to add is a data access object for DynamoDB. So I've already prepared something for that. I'm going to create a new subdirectory, util, and in that subdirectory I will create a file, DynamoDAO.js. And again, I just copy and paste the source code. Don't worry, it's all in my repository and you can look it up there, but we don't have the time to go through it in too much detail. Basically, what I'm going to do here is I wrap my DynamoDB document client in a class and provide some higher level methods that take as an input the model, so my article, and a callback. And so I pass in my callback into the Dynamo method, such as a put method. So if the put method works out correctly, I call my callback here. So I would pass in the callback from my Lambda function here to create a new item. And one more thing that I want to create is a controller. You can judge on your own if you need so many levels of abstraction or if fewer levels would also do. So I'm going to create a new file, controller.js, and I'll add my controller code here. And what this does is it wraps around my DynamoDB data access object and wraps or does the error handling here so that I don't have that in my main code. And here I already updated the create, delete, read, and update methods accordingly, so now they are much shorter. I import the create article method from my model.js file here. I import my DynamoDAO and I import my controller. And the way I use them is I use the create article method here to create a model from my event, and using my callback. In case there's an error, I can send the error to my callback function. And here I'm creating a DynamoDAO, passing in the Dynamo client from up here, and the name of my table, which is block table. And then I'm creating a controller, my article controller, passing in my DynamoDAO. And here, last but not least, I invoke the create article method on my controller, giving it my model and my callback from up here. And so the delete method looks very similar. Delete article, read just changes here, read article, update just changes here, update article. So I guess there's more option to simplify this, but let's leave it as it is right now and deploy our service. We have deployed our service, so let's invoke it. SLS invoke. And again, I'm going to create to invoke the create article function first, giving it the event in my event.json file. And this creates a new article. Let's switch to the AWS Management Console. And here we can see I have created a new article with the name Hello Universe. And now let's invoke. Okay, I've created a new article, and maybe for a change we can invoke the read article method. For that I need to specify the article ID. Let's switch to the AWS Management Console and copy one of the article IDs like this one and paste it into our event.json file. So you need to stringify it like this because we are using the Lambda proxy approach. So article ID is the article ID that we just copied from the AWS dashboard. And now instead of create article, we can also do a read article. And there seems to be a bug somewhere. So let's check the logs. So let's invoke the read article function. And we get back hello world. Let's try update. Instead of hello world, let's replace it with hello universe. And instead of read article, we do an update article here. Okay, let's read it again. And it says hello universe. Let's switch to the AWS Management Console. Hello universe. And last but not least, let's see if we can also delete articles. Let's switch over again, refresh the table, and it's gone. That's it in this video. In the next video, we are going to try out Cognito to identify our users. See you there.